Hello everyone, I welcome you to Academy. In this lesson, we aim for becoming the aware of how to design Voronoi surface lattices, and there we aim for what are the geometrical parameters we need to provide to create the Voronoi surface lattices, okay, and what are the things we require furthermore. So we will discuss all of them in detail. Here we will we will select one particular body. It can be any shape. So in today's lesson, we will create the surface Voronoi lattice on particular cubic lattice. So later on we will discuss other bodies as well. And within this body, we aim for creating the surface Voronoi on the surfaces of the particular cube body. So let's discuss. Yeah, here first we have to give the name of our file as surface Voronoi lattice structure, okay, and we can give the description as the design of surface Voronoi lattice structures, okay, structures, and our section name as surface Voronoi lattice structures, okay. And if we want to add any comments, we can also add the comment as well. I hope if you're not able to find, but I'll show you. Yes, so our aim of this topic is to generate the or design surface Voronoi lattice, okay. For that, let's select the Voronoi, like a stochastic block, okay. For that, we can either go to the lattices tab, and as we discussed earlier, we can go to stochastic block. There, from here we can select Voronoi surface lattice, okay. In previous lesson we have discussed Voronoi volume lattice. So in today's lesson we are going to generate the Voronoi surface lattice. What it is saying here, oh sorry, suppose if you want to know about this, yeah, like if you go here, it is clearly mentioned that creates a lattice from a Voronoi diagram of a list of points restricted to the surface boundary of a body. It means we have particular body, and the body, we have its a surface, and we need to restrict to some points. It is up to us how many points we need to give on a particular surface. With that surface, we are trying to generate the Voronoi lattices. Okay, yeah. Come to Voronoi, like the surface lattice block. So here, what do we observe? We need to define three geometrical parameters, isn't it? What are they? One is seed points, and the second one is thickness, and the third one is mesh. So here it is very important to define the mesh type also. So accordingly, we are going to generate the Voronoi surface lattice. Okay, as I said, we can also get this block directly from here if you know the name of it, like Voronoi. Okay, like if you see here, after typing Voronoi, we have various type of blocks. From there, we can select the surface lattice block, isn't it? Like this way also, we can get the Voronoi surface lattice block. So let's delete this. We have deleted. Now let's define each of these parameters one by one. Seed points. It means we need to give the points, number of points on the particular surface of a body. So how to define it? How to define these points? So let's double click here, and what do we have? There are various blocks. To utilize or to give the seed points. Okay. So if you see one by one, but in today's lecture, we are going to give the seed points on a particular body, not on plane or not on volume mesh or not on mesh. So if somebody wants to give on them, they can freely give the seed points and generate the particular Voronoi lattices. So in this means these many ways one can able to give the seed points, isn't it? So let's select the random points in body. Okay, random points in body. So let's select this block. Now again, so within this block, again there are various geometrical parameters, okay. So we need to define them, each of them. One is body. Yes, we must require the body. On that particular body, on the surface of that body, we are going to give the seed points, and we are going to generate the respective Voronoi surface lattices, isn't it? So let's select the body first, and as we know that either we can double click and type here. So body means it can be cube, it can be cylinder, it can be anything. You can design some other parts from outside also. If you have some other complex geometry or complex body, like suppose mouse or pen or any kind of body. So let's go to create, and from primitive tab, primitive block, we can get various 3D shapes, isn't it? So let's select cube as our body, and make it as a variable, so we can use this block again and again. Okay, so let's write this as a cube body. Okay, now here it has a two parameters. One is center point. If somebody wants to change the center point, they can freely change. So we will go with as it is. And if somebody wants to change the size of it, they can freely change it. So let's place this above it. And if you want to add the comment, as I said, here there is one pop-up came. So if you want to add any comment here, like suppose we are going to learn how to design surface Voronoi lattice structures. Okay, so this is how one can add comment, so that later on they can freely identify what exactly we have done on a particular block. So this is how one can able to give the comments, and give the section name, and label the description, and give the file name. Okay, so now come to the point. Now let's place this block within our body block, and later on it is where now the most important parameter, geometrical parameter, that is point spacing. So it has much more effect on a particular Voronoi structure, as we discussed earlier lecture as well. So what I can suggest, try to give the point spacing more than the size of the, like less than the size of the particular body. Suppose we have the size as a 10 mm, isn't it? So it is better to give the half of it, like 5 point spacing. Okay, 5 point spacing, it is better. So we can come from higher to lower, don't go from lower to higher, because the more point lesser point to space, the structure going to be complex. So it is better to come from higher to lower dimensions. So let's give the half of the our like body's dimension, it has a 5 mm. Now here see, what do we observe? There is blue dots, means blue points are highlighting within our body, isn't it? So if you see them clearly, let's minimize this, and yeah, these many points generated as per our point spacing. So now random seed means it doesn't have that much effect. It means it can distribute the seed randomly. So based on like points will remain same, but the distribution is like a random. So let's go with the 1 mm only, 1 point random seed only. Now now next important parameter, thickness means our beam thickness. So in as we are generating the Voronoi lattice, it doesn't have any surface kind of structures, it has only beam or stud based structure. So it is important to give the thickness here, thickness, stud diameter or beam diameter. So we have to define it. So let's give the point no, let's give the thickness as a point like a 5 mm or 3 mm. Okay, so we have given point 3 mm. Now the final parameter, that is mesh. So we can discuss about the mesh later on, but for now we have to define anyhow. So let's double click here. Here we have various type of blocks, isn't it? As we discussed earlier, as we have here implicit body. So we have implicit body, so that's why we have to select the mesh from implicit body itself. So let's select this. Now again, within this block we have to define these many parameters, but it is not it is no need to give the sharpen or simplify. They are important only in the case of, like if we are going for finite element analysis, like structural finite element analysis. Even nTopology itself suggesting that minimum feature size, it is optional, so it is up to you. But here we need to define only two things. One is body and tolerance. So let's define the body as it is. Let's place this cube within our body, and now tolerance, as we can give the tolerance here. Again, tolerance, so it is recommended that come from higher value to lower value. So let's, as we have our size of the body is 10 mm, let's give the tolerance as either 1 mm, or let's give the tolerance as 2 mm. Let's give, we can come 2 mm to lower also, even 5 mm also we can give. It is like it's a parametric parameter, so we can vary it. Now it started generating our Voronoi surface lattice. Yeah, finally we have generated Voronoi surface lattice of cube. What do we observe here? Here we have the beams. We have beams and they are connected each other and there is a wide space within the beam, means inside and outside also. It means let's highlight our body. See, this is our cube, isn't it? Now our Voronoi is generated on the surfaces of the cube, isn't it? So this is how one can able to design surface Voronoi lattices. Why it is important? For suppose if you want to like glue, or if you want to like add anything, so it will help us. For suppose if we consider the application, like there is a hand patch, hand got damaged, we need a band. So hand itself has a complex structure, isn't it? Our hand. So to cover that body, we need some hand bandage, isn't it? So to design such kind of bandage with a surface lattice, we can go for this application. We can go for this option and design particular surface lattice. Okay, this is how one can design surface lattice. Now we can play with our parameters. Like now, what do we observe? There are less beams. No, for suppose if we increase the point spacing, decrease the point spacing as a 3 3 mm. Now let's see what is going to happen. See, now the number of beams increase, isn't it? So like this one can play with like point spacing and generate respective Voronoi surface lattice. Okay, this is how one can be able to now see how beautiful it is. Lovely, isn't it? Okay, till now I hope you understood how to design Voronoi surface lattice. Okay, now we can also play with the tolerance if you want to give the tolerance as a 1 mm. So but it takes a little higher time to generate because tolerance. So see, although it doesn't have that much effect on particular Voronoi surface lattice, so here the most important parameter, that is point spacing, it has much more effect on the particular generated Voronoi surface lattice. So you can design this type of surface lattices by selecting any kind of bodies. So in our today's lesson we have selected cube. So I hope you understood till now. With this, I'm concluding. So let's see its cross section view also. See, inside the empty space, it is fully generated outside of the surface of particular body. Now we can see it, isn't it? So this is how one can able to design the particular Voronoi surface lattice. So and I can suggest you go through these steps and practice them again and again, so that you can become expert of this particular tool, and you can use them for your particular application. And I will also explain you in future lectures how to exactly export this file, and we can able to go for simulations, we can able to use them for simulations and print them. Okay, I hope you understood till now. So let's recall. So we have achieved like Voronoi surface lattice by considering the cube body. So initially we have taken the Voronoi surface lattice block within lattices block. Okay, from here we have selected the Voronoi surface lattice, and later on we have defined our particular body as a cube from creative tab and primitive tab. So here you can select any other kind of bodies as well. So it is up to you. So I can suggest that. Now I can suggest, and I am also giving homework, or it is up to you. If you want to practice any other shapes, you can freely practice them, and if you have any doubts, please let me know in the comments. So I will explain you, I will try to clarify them. So you can use any type of body from here, and then we define the particular like point spacing, and later on we also selected the mesh from implicit body, and thereafter we defined the tolerance. So this, after that we got our particular Voronoi lattice structure. So with this I am concluding. I hope you understood and you have learned something. So keep searching and keep sharing, keep shining. Thank you.